Okay, just a few announcements first. So, you know what? Let me also turn on the other projector. But let's have a look at that first. So for announcement number one, your Lab 1 marks, just for the programming part, which is about 3% of your final grade, is available. You can run this command over here, feedback 3311 Lab 1. That's what you can do. If you got any concern, don't panic. Just drop by my office hour tomorrow, Thursday, between 1:30 and 3:30. Okay, we'll sort out the issues with you. Okay. Second one, about the lab test number one, which will be next Wednesday. So for next week, please make sure you manage your time well. Wednesday will be the lab test number one, and Friday noon will be the when the lab two is due. Okay, so please make sure you manage your time well. I just want to show you, if you go to the page over there, actually I don't have that here, but if you go to the lectures page, you will see that there's one document there called the PDF, called Lab Test 1 Guide. It tells you what's covered and the rules, read them over. Okay, I'll just briefly mention. So what you gotta prepare is you gotta go over all the slides we have covered so far. You don't have to study the iterator pattern, okay, only the singleton in that lecture slide, okay? And also you have to watch the tutorial videos that I assigned, is also on the guide. And also all the sample codes I posted, you should really study them. And also lab number one. For lab number one, in principle, I'm not going to distribute a solution. However, if you want me to go over your solution, I'm happy to do so. Just schedule a time with me. Okay? Try to do that. Okay? Now, what's going to be the format for the lab test? It's going to be, part of it will be you have to do some little bit programming, like writing postcondition, precondition, a little bit coding in iPhone Studio. And you may have to write answer some written question as well, maybe some concept. So you like a combination of both. So you really want to study all the materials. Okay? It's not just about programming. Also, I'm going to ask you some question about concept too. Okay. So now, today I want to start with, remember we talked about a singleton pattern from last time. I just want to finish that by going over the bond diagram. Okay? So this is the so-called bond diagram here. Bond diagram. So whenever we learn some new design patterns or show you some idea, it's better to show some diagram to really give you some overview picture before we try to go into coding. And this is something you're required to do for your lab number two, to show how the classes interact with each other in one single page. I want to go over some concept with you in the bond diagram, so make sure you cover them in your lab number two. So first of all, I want to show you, first of all, you can see that there's something with a dashed line over here. So 1, 2, and 3. So these are the clusters. Okay, you can see in lab number two, you got different clusters. And you should really put the name of the cluster and then what's the class inside. And there are two kinds of view you can show about a class. One is, for example, like this. You simply show the name. It's called a compact view of the class. Okay, so this is called a compact view. Okay, and the other one I want to draw your attention to is, for example, here. So you have seen that for lab number one, where you have to show some contracts and invariants and also some feature names. In that case, it's called the detail view or contract view. So this is the detail view of your class. Okay, and then you got different kinds of arrows over here in this case, in the singleton pattern. So first of all, you can see over here you have an arrow like this with a arrow on the right. So this means client-supplier relationship, okay, as I said before. So this is client-supplier. You always have the client that points to the supplier. In this case, we're saying that the data axis is the clients of data, okay? So you got a client here, you got supplier here. And when you actually show the arrow here, you have to put the name of the attributes in this data, in this case, okay? And one more thing, remember when we talked about the singleton pattern last time on Monday, we said that we declare data access to be expanded, right, just for the efficiency. In this case, the way you show the expanded classes is by drawing the client-supply relationship a little bit differently. You can see the vertical bar over here. So that one's for expanded class. So when the supplier happens to be expanded class, you show some vertical bar to distinguish. Okay? I believe I cover everything that's here. And if you want to show inheritance, as I said before, for example, if you have, let's say, slot status for your lab number 2, you have to say somehow one of the subclasses is, let's say, unavailable slot, something like that. Okay, that's how you show the arrow. You will see that when you go to draw.io, so that's the tool we're going to use for this course. It's free. It's hopefully not too difficult to use. For that one there, remember the library I gave to you for lab number 1. You can see that there's a template there. You got everything you need. Okay, I'm just going through all the components there. So make sure you understand all these ingredients over here. I may ask you a question as well in the lab test. Okay. Any questions about this diagram here? So somehow this diagram shows you the overview of the architecture for the Singleton pattern. You can see you got expanded class over here, and also you have some invariant here. You got client supplier here. You got different relationship here. So that's how they show the architecture, okay? Rather than showing the code. So both are important. Yeah.
So we'll be expecting written questions as well.
Yes, they will be. Yeah. So I think maybe most likely you don't have to write on the paper. I might just include some text file for you in the project. You just gotta type in the questions. Yeah. It's not just about programming. No. Okay, any question about this before I move on? Okay, so today I want to cover the complete story about making copies of objects. Remember in lab number 1, there was kind of like a background section there where I talk about imp versus imp.twin. I would like to talk about it today because it's not the complete story. The complete story is sometimes making twin may not be sufficient enough. You may have to say deep twin, which means you gotta make something that's more than shallow copy. Okay, I'm gonna show you today. That's really worth learning because I believe you got clone and deep clone in Java as well and in many other languages. Okay, if you know no question about Singleton, then we are done with Singleton. Okay. So now let's go to that. I want to just talk about general concept first, and then we'll go through one example in detail. Let's see how we can copy objects. Okay. Let's make some assumption here. Okay. For the first, when we introduce the 3 kinds of copy, we got reference copy, we got shallow copy, and we got deep copy. 3 kinds of copy. For these 3 kinds, I'm gonna just make some little bit abstract example first, and then I'll show you the concrete one as well. Okay. So now, let's say we got 2 objects, C1 and C2. So there are 2 variables. They are of the same type C. Okay. You can have decoration like that, C1 and C2 of type C. And let's say there's only one attributes of the class C called A, only one. So now, and for C1.A or C2.A, remember what we have learned about, there are 2 kinds of types in IFO. You can be either reference type or expanded type. When you talk about reference type, you talk about addresses for the objects. For expanded type, there's no address, just the object itself. Okay? So we have to take this into consideration. Okay, so this is kind of the setup we have. Okay, let's try to understand this diagram first before we talk about the 3 kinds of copy you can have. So you have, so this is how I visualize each object here. You can see there's a box with title C, which means it's an object of type C. And we have C1 is the placeholder for the address of this particular object. So we got C1 and we have C2. At the moment, they are separate objects, completely independent. And there's only one attribute for class C, which is A. And A here may point to something else. And I just put it like a cloud, C1.A. C1.A can be as complicated as possible, as you like. For example, C1.A may just be as simple as like an integer, very simple type. Or it can be some very complicated object structure at the runtime, right? So C1.A can be just anything you can imagine. Okay? Any question about this basic setup? I'm gonna see how we can make different copies. Okay? The first one is very easy. This first one you learn pretty well also in the previous Java courses. The first one is called reference copy. How do we do reference copy? You can simply do a simple assignment, call it equal. In Java, I just say equal sign. So now what does this mean over here? When I say C1 is assigned to C2, because we know that reference variable does not store the object itself, Each one of them stores the address of certain objects, right? So now, when I'm trying to do this assignment here, I'm not really trying to copy objects. I'm only trying to copy addresses. So I'm trying to copy the address that is stored in C2 and store that into C1. That's what I'm doing, okay? This is the cheapest copy you can have. You just have to duplicate the address, not the entire objects, okay? So now, after this, what you will have is a diagram like this. You can see C1 used to point to the object over here, but now after this C1 is assigned to C2, C1 is not going to point to here anymore. It's going to point to wherever C2 is pointing to, right? So that's the reference copy we're having. Very cheap, just duplicating the address. And one thing to note, once you have done this reference copy here, C1 and C2, both of them store the same address. They point to the same objects, and we call this aliasing, which means any updates you're trying to do by any one of them is going to be visible to all the other references, right? So that's aliasing, okay? Yeah? Does C1? Oh, I see what you mean. Okay, the question was, let's say we do this, you can see this object that used to be pointed to by C1, there's no reference to it. Good question. First of all, you don't have to worry about it because in IFO, just like in Java, you don't have to free the memory yourself like in C. So they have something called automatic garbage collection. So what they will do is they're going to analyze the objects. If there's nothing pointing to it, in that case, they can trash that away. Okay, yeah, that's not something you have to worry. Okay, okay, good. Any question about reference copy? That one's very easy. Okay, now the second one is slightly trickier. The second one is called shallow copy, but I think another name might be a little bit more informative. It's called a first level copy, which means we're going to somehow create a brand new object, but the copy is only going to be done at the first level of attributes. Okay, let's see how that's going to happen. So this is how you do it. You say, now if you say C2.twin, what this will do, first of all, it's going to create a brand new object that is independent from C1 and C2 implicitly. And then somehow it is going to do some copy at the first level from C2. And then assign that reference of the new objects into C1. Okay, let me show you some diagram here and I'll go over some points. Let's see the diagram first. So this one over here, you can see there's an intermediate object called C3. This is what's done behind the scene for you. Okay, let's just look at C1. C1 used to point to this object here, and C2 used to point to this object here. That's what used to happen. Now, step number one. IFO compiler at the runtime is going to create a brand new object implicitly. Let's just call that C3. So we got three objects that are completely independent at the moment. But the copy is only up to the first level, which means only create that object. However, what about the attributes? Remember in class C, we got attribute A. In this case, should we make a complete copy of C2.A? No, because that's shallow copy, which means we only make a reference copy of that attributes, which means you can see this new object we just created is going to, its A field is going to point to that C2.A as well. So that one is really aliasing. You can see the aliasing does not occur at the first level, it occurs at the second level. Okay? So now, and then after that, we're going to let C1 point to this new object here, right? So now you can see that C1 and C2, are they pointing to the same objects? They are not, right? Because you can see C1 is pointing to this object here, and C2 is pointing to this object here, so they're different. Okay? So this is already different from reference copy. However, if you look at C1.A and C2.A, they both point to this cloud over here, right? So you do have aliasing at the second level over here, and on the attributes level. Any questions about this, about the twin? You first. Correct, correct. That's a very correct remark. The remark was, let's say now if you try to change C2.a's value over here, of course, it's going to be visible to all the other references pointing to the same objects. Of course, C3 C1.A will also can see that. Yeah. Yes.
So the set attribute values of the shallow copy are basically a snapshot. However, when you're just doing the aliasing, if you change one, the other changes. This one, not so much.
Yeah, this one we kind of delay the aliasing, right? You can see the reference copy there, we got aliasing right away between C1 and C2. But now for a shallow copy there, we kind of give you some brand new objects only at that very, very first level. And then from the attribute onwards, we still make aliasing. So in some way, you can think about shallow copy is slightly more expensive than reference copy because you got the additional cost to create one new object there. However, it's not too expensive because for A1, for C1, for C2.A, you don't really have to duplicate the whole thing, right? Any question about this, the shallow copy? Okay. Okay, I would say shallow copy may be the trickiest part among the three because for reference copy and deep copy, they go to the two extremes. And somehow the shallow copy goes somewhere in the middle. So you have to know why I call it the first level copy. Okay, you can read it over. So that's something we mentioned already. So the aliasing happens only at the attribute level. Okay, so now what about deep copy? Deep copy somehow goes to the other extreme as opposed to, yes? You mean over here? Yes. Okay, so the question was how did the attribute copy work? Okay, you can see that this something mentioned here. I'll just point it to you. First of all, you can see the way we initialize the attributes is by using a reference copy. Okay, so let's say this. Let's say this is C2 over here, right? Okay, let me just draw some diagram to show you. That might be. Okay, let me just use diagram. Okay, let me just add another page over here. Page below. Okay. So now let's just draw it very quickly. So we got C1 over here, which points to C over here, and attribute A, it points to some cloud over here. So this is C1.A. And then we got another independent object over here, which is C2. And then we have C2 over here, and then we have this C, and then we have attribute A, and then also points to some cloud, and then C2.A. That's what we start with, okay? Let's say right now we have this line over here. We say C1. We say C1 okay, we say C1 is assigned to C2.twin. Okay? So how do we do that? Okay? The principle is, first of all, is easy. First of all, you have to, let me use red. So this will be the change. First of all, you gotta create a brand new object of type C. And with attribute A. That's step number one. And then, now the question is, how should we deal with this part over here, the cloud? That part can be arbitrarily complicated, right? It can be some very complicated object there, or it can be just integer. So now, for the shallow copy there, we make a very simple solution. You simply just copy the address of this cloud over here, and then make this object here point there. That's what you do, right? And then let's say this is C3. So C3.A is simply assigned to C2.A. So this is what's done behind the scene. Just a shallow, just a reference copy at the attribute level. And then after this, you're gonna say now C1 is not going to point to here anymore. It's going to point to this new object here. Okay? So now one more thing to mention before I move on to the deep copy. It's very important to notice that when you say C1 is equal to after this line, let's say after this, after the copy over here, if you check C1 is equal to C2, okay, versus If you say C1 dot A is equal to C2 dot A. So let's say we got two equalities to check. According to this diagram, what would be C1 equals C2? False, right? Very good. That'll be, because they're simply different objects, okay? I'll say false. What about C1 dot A? Right? C1 dot A equals C2 dot A, right? Very good. So that's true. Okay? So this is also different from the reference copy. Okay? Yes? So say it again. C1 equals C3. C1 equals 1. Okay. You know what? From the diagram, yes. C1, the question was, if we do C1 equals C3, indeed, C1 and C3, they actually go to the same object, right? Yeah. Of course. Yes.
So if C1 equals C2 from 3 should be true.
What?
We don't have,
No, no, no. This is not equality. This is assignment.
if it's equal, then it should be true.
I,
Because we don't have C3 created. C3 is suffering.
something is hidden, but I'm just saying from the diagram, you can also think about C1 and C3. They point to the same thing. Right? Okay. Any questions? Yes. You don't really compare, but I'm just saying in the diagram, I'm trying to show you that C1 and C3, they point to the same thing. Of course, once you, somehow C3 is gone, you cannot see it. Once you have done the twin. Of course, you don't really keep a reference of that. But I'm just trying to say, somehow, if you just compare that, they are the same references. No, it's not really C2 the twin. It's actually the objects that is created behind the scene. Yeah. Mm-hmm. Yeah. Good question there. Now, you can see that because of this, that's a good question there, we have C1.A is equal to C2.A, right? They are the same references. The question was, if I try to somehow make some changes over here, let's say I do some change over here. Yes, it is going to affect. Let's try to link this to your lab number 1. Remember in the lab number 1, you only did imp the twin, right? It's actually because of the following reason. I'm not sure if you noticed that. The way we modify the array container, we never modify the contents of the string. We only modify the order of the contents, right? So in some way, we are not really changing C2.A. I'll illustrate that to you in the complete example. But somehow, for lab number 1 purpose, using twin will be enough. But somehow, in general, if you want to modify the contents in the collection, in that case, just doing twin would not be enough. Okay, yeah. So in this case over here, if you do a change over here on C2.A, of course it's visible to both C3 and C2, of course C1 as well. It's visible. Because it's aliased. Which means, yeah, because yes, after you have done a change, then C2.A is going to see the change, and also C1.A also is going to see the change. They will see the same change.
So what's the difference then between the aliasing and the shallow copying?
So here, you see, the aliasing does not occur at the object level here, right? You can see the aliasing only occur here. Let me just try to use a different color here. You can see this is the aliasing, right? This is aliasing, which means if you change the object here, it's going to be visible to both worlds, to both references, C1 and C2, right? So that will be C1.A and also C2.A. So these will be the two references that will see the change.
Okay, C1 won't be affected.
Just C1 itself wouldn't be, but C1.A is going to be affected.
Okay,
Yeah.
the very top.
But the very top, no, because you're not modifying that, right? Yeah. I would say usually reference copy. I would say when you are doing contracts, let's say, when you are writing especially when you're writing postcondition, which I'll go over. When you're writing postcondition, you want to compare. Let's say you have some array attributes, right? Array of account, which I will go over. In that case, if somehow you only want to change one particular spot in the array, in the implementation, now you want to compare the array before the change and the array after the change. In this case, if you only make a reference copy, they are really pointing to the same array. In that case, you don't really see a change. That's something that I try to explain in the lab number 1. I'll explain it again. But if you do the shallow copy there, it depends on what kind of change you're doing. Okay? So what about we'll leave that maybe until the real example. Yeah. Any other conceptual confusion if you want to raise up before I go on? Yeah. Yeah.
Can we do a reference copy for deferred class variables?
Deferred class is like abstract class in Java, so you cannot instantiate them. So there's no copy. Yep. So the question was, can you do some deferred objects dot twin? The thing is, you cannot really instantiate deferred class. It's like abstract class, right? Hey, any other questions? Are we okay? Okay. It's not really concrete yet. I'm still talking about a little bit abstract. Okay, so let's leave that maybe to some concrete example. Okay, what about deep copy? Now, deep copy is really the other extreme. So now, what you can do, you can say C1 is assigned to C2.deepTwin. In this case, remember for the shallow copy there, how did we deal with C2.a? We didn't really recreate a whole cloud. We simply just make a reference to it, right? But now, for the deep copy there, what you do is you simply just create another cloud over here, right? So now C2.a and C1.a, they are not the same anymore after the deep copy. Okay, let me maybe use that to illustrate quickly. Okay, let's now do this, add page below. Okay. Over here, we still have C1, C, and A. So that's the cloud for C1.a. We also have C2 over here, which is of type C, and then we also got a cloud for C2.a. Let's say what we want to do now is deep twin, okay, deep copy. What's going to happen if we say C1 is assigned to C2.deepTwin? Okay, conceptually, this is how you can think of it. First of all, we are still going to create the object first. So we're going to have under the hood C3 over here, and then C and A. Okay. So now the question again is, how do we deal with C2.a? What we used to do for the shallow copy, we simply copy the address of C2.a. That's what we used to do. But now we don't do that anymore. You have to somehow recursively copy the whole cloud and then make a reference to it. So now, imagine that we're going to create the whole cloud, which is completely independent from the old cloud over here. And then we're going to make C3.a point to it. Okay? And then C1 is not going to point to the old object anymore. It's now going to point to this deep twin. That's what happened. Okay, any questions about this? That's deep twin. You can see that. So now C1.a is completely independent from C2.a. They are not the same anymore. Questions?
Yeah, well, what would you do if it was like 3 levels of knowledge,
Actually, so this is the thing. For reference copy, it's basically level 0. You don't do any copy, right? Just copy the address. For shallow copy, there's first level copy, only making a reference copy of your attributes. There's no operator for doing this third level, fourth level, fifth level. No, you cannot really tailor that. You cannot do that. So you either go for reference copy, first level, or you go for the deepest level. These are the only 3 you can do. Yeah. For sure. Let's say this. Let me just make the, I see what you mean. Here's the difference. So because now I only got one attribute, so you cannot really see that. Let me say we got two attributes. How about that? Okay. It's good to clarify this, so once we get to the concrete example, hopefully much easier. Okay. So now, let's extend C a little bit. Let's say we got two attributes there, A1 and A2. Okay. So now let's say we have C1 over here, and then we have C. I'm going to have A1 and A2. Let's say A1 is very simple, just integer. Okay. Let's say 2. Okay. And then C2 over here is similar, just independent objects. A1 and A2. Let's say the value is simply 3. And then we still got this cloud over here, which is C1.A2. Also, we have this cloud over here. We have C2.A2 in this case, right? So now let's say we do a reference copy. If we say C1 is simply assigned to C2, right? In this case, just a reference copy. What it would do is C1 is not going to point to here anymore. It's going to point to over here, right? So now the aliasing tells us C1 dot A1 is, well, basically, let me just put it this way. C1 is just equal to C2 after reference copy. Okay, let's say we want to do a change to over here. If I want to change from 3 into 5, it affects both of them, right? That's a reference copy. Okay, good. So now let's see the shallow copy. Everybody follow? This is a slightly extended example. Okay, let's do the shallow copy. So now I'm going to apply the same structure. So let's say we got C1 over here, and we have C, A1, and A2. Let's just make the same value. It's 2 and 3, okay? 2 over here, and that's the cloud we have. C1.A. Also, we got C2 over here, and here we got C. We have A1 and A2, 3. And this guy here is C2.A. Okay? So now, what's going to happen if we try to do C1 is assigned to C2.twin? What's going to happen is, we're going to have this. Let me just forget about C3. I'm not going to include error here. You got C here. So you got A1 and A2. So we're going to make a copy of every attributes. In this case, 3 is an integer. So we simply copy that here. Okay, and then we also have A2 over here, but it's a shallow copy. So only make a copy of the reference to the cloud, like that. And then we're going to make C1 point to over here. Okay, now, if I try to change C2.A1, let's say. Now, if I try to do the following change, if I change this from 3 to 5, is it going to affect this value here? No, right? No, it's not. So this, sometimes you got aliasing, sometimes you don't. In this case, you don't, because they are primitive type, which means like integer or simple values. So you don't really affect that. Okay, any question about this? Are we okay? Or, okay, maybe let's see more examples, okay? Okay, now that's good. So this example here, let's try to do some simple exercise over here, okay? Quickly, and then we'll move on. Let's say we got this. Let's say we start with this. So we got some reference called A over here. So A points to this object structure over here. So the object here has 3 attributes. It has name, landlord, and loved one. Okay, we got 3 attributes. And somehow the landlord points to itself. right? And also the loved one just point to another object over here. And that object there also got different attributes there, right? That's kind of the object structure we have. Okay? Let's think about what's going to happen if we say B is assigned to A. What are we doing here? Do we have to recreate any of the object structure? In that case, we don't have to. So all we got to do is we're going to say we're going to have some address called B, and it's going to point to exactly where A is pointing to. And that's it. That's what you do when you make a reference copy, right? So B is assigned to A. That's all you do. As you can see, it's very cheap. Just copy the address of A into B. That's a reference copy. What about shallow copy? The same structure here. For the shallow copy here, first of all, we have to first of all create the same object structure over here, right? And then we got 3 attributes. For each one of them, we're going to only copy the reference of that. We're not going to go any further, right? So now, eventually, we're going to have C that points to these new objects. But for this object here, every attribute is going to be just a reference copy, right? That's why it's shallow. In this case, we're going to have, for example, the string value. I'm just going to copy over here, right? I'm just going to repeat that here. The string value. What about the second one? How am I going to do that? This attribute here, asking this. How do I make that copy there? Should I create any object here, or should I just copy the address? Exactly. So what's the address of this link? It's just that object itself, right? In that case, what I would do is I'm going to say now it's going to point to wherever that it is pointing to. Okay? Now, similarly, what about this one here? Let me use a different color here. What about this one here? Similar, right? So which one should it point to? 01, 02, or 03? 03, good. Exactly. Now it's going to point to 03. That's shallow copy. So far so good? Hopefully that's a little bit better, hopefully, yeah. If you're still really puzzled by the general example I made about C1.A, don't worry too much. Let's see the concrete example. Hopefully that makes more sense. Okay. Any question about shallow copy? Are we okay? Okay. Now for the deep copy here, I just want to talk about this example specifically. We don't really have to learn about how to make a deep copy. It's really tricky because, for example, you can see that over here we have some circular structure over here, right? You have a reference that points to itself. So when you want to make a recursive copy, you got to be careful with the circular structure. But for this course, we don't have to deal with this. Okay? It's down to the implementation level. But conceptually, you should know how to do it. Okay? Now, how do we do a deep copy? Again, we're going to create a new object over here. Still a new object. We've got 3 attributes there. And then D is going to point to this deep copy. Right? So now, what we got to figure out is how to do the copy for each one of them. It's going to be a deep copy, which means everything has to be like a mirror to the original one. Okay? So now, rather than drawing, I'll just show you how it looks like back in the slides to save time. So what you will see is something like this. You can see D over here is going to point to some complete fresh copy of the original object structure over here. You can see over here, right? So this new copy here has nothing to do with the original copy. They're completely independent, completely. Okay, that's deep copy. Yes? Okay, here I can see why you have this question here. The diagram over there is simply just from the textbook. I think what they draw is slightly not so precise. Okay, think about this. What's the type of string? It's reference type, which means when you talk about string reference there, it's just a reference. It's an address to some string objects. So you would just make if you do shallow copy, you're only making a copy of the address and just link to it. I think for simplicity here, we just include the string inside. Okay? To be a shallow, if you want to, I don't quite get your question yet. Okay, just, can I? Yeah, say it again. I don't quite get it. Oh, I see what you mean. Okay. So the question was this. So this one is a slightly different issue. Okay. So the question was this. If I simply have something like this, oh, of course. Good. Okay, so now the question was, if I say S1, S2, they are simply just string. S1, S2. Let's say York. Well, you say route, just say York here. The same string. The same string, right? After this, I believe S1 and S2, they will be the same. It's a slightly different issue here because for efficiency, it's the same as Java. If you try this in Java, they will be the same string as well, the same string reference. It's a different issue here. So now, for compiler, for efficiency reason, because they will somehow, when they compile your IFO code or Java code, they will notice that these two string literal you're talking about, York and York, they are actually the same string. At the runtime, they don't have to create two separate objects to really do that, right? So they will simply let S1 and S2 refer to the same string objects at the runtime. However, if you try the following, that'll be a little bit different. You can do creates S1 dot make from string. So there's a constructor from the string class, right? You can say this one is York. And then you have another one, creates S2 dot make from string. And then this is also York. In this case, a little bit different. So for each one of them, it will be a separate string objects. In that case, S1 and S2 will not be the same. Okay. This one just a little bit aside. Okay, so now that's about the general idea about shallow copy, deep copy, and reference copy. Any questions? You want me to go back to any points before I go through some complete example? Yeah. Say that again.
Object 6 is copy because log1 points to object 7 and points to object 6.
You're talking about deep twin, right? Okay, basically, for the deep twin, it basically just recreates the whole object structure like a mirror, right? So over there, you can see that, you can see in the initial situation over there, you can see, for example, let's say for love1 over there. Love1 actually points to object 3, O3. That's why over here, love1 in the deep twin copy there, it points to another brand new object which is called O7, right? You just mirror the whole object structure, right? Somehow algorithmically. But as I said before, we don't have to know how to implement that. It's quite sophisticated. Okay, let's now go on to see some application of deep copy, shallow copy, etc. So the most useful application for this particular course is we can write contracts to use deep copy, shallow copy, etc. Let's see how we can do that. Okay, so now let's go there and see this new lecture here. Okay, so now let's review very quickly about how we check contracts at runtime. Okay? First of all, we know that all the contract Boolean expressions, and then let's say we have some feature over here, let's say withdraw over here, okay? And before the feature call, before we call the feature, what do we have to check? We got to check the precondition, right? And then it's called the pre-states. Let me just mention something here on the pad, and then I think the slide will be done. Okay, let's say we talk about this particular withdraw method here. Let's say withdraw. Over here. Let's say we have some amount, integer. And then we have require something here, and then we do something here. Let's say we have ensure. That's really important because this lecture is mainly about how you can use the twin and deep twin in the contracts. First of all, let's say I got something like this. I say balance is equal to the old balance minus A. Okay, let's say we have that. Okay, now how does that work? Let's see, before the feature is called, we're gonna check if the precondition is right or wrong. Right? After the feature is called, we have to check if the postcondition and also the invariance is right or wrong. Okay, that's kind of the how you check. But now it's a tricky thing here. You can see that when we say old balance over here, we're really talking about the balance before we try to do withdrawal. So that's why it's called old, right? And old is actually a keyword in IFO. So the way IFO does for you is, it's going to say in the compile time, it knows that at the end of the feature call, you want to really compare the new value of the balance and old value of the balance. You want to compare them. However, if you don't have a way to save the old value before the feature is executed, it would be too late to compare, right? So now, what IFO will do for you is, it's going to analyze every postcondition you have. Whenever they see some old expression, for example, this one here, old expression, okay? In this case, the thing that will be applied to the old is simply just balance, okay? They will do some implicit capture for you, which means before that, so this one actually corresponds to the following assignment. They will simply say some old balance, so that's just a variable, is assigned to, just balance. Just that. And notice that why is this just balance? Sorry, calling equal. Why is this just balance? It's because we got balance here and we only have balance over here. Whatever you put besides the old is going to be applied verbatim into the right-hand side of the assignment. That's how they do the cache. Okay? Now, let me just make some more illustration to you. Let's apply that to a little bit more implicitly, more directly to your lab number 1. At the page below. Okay, so now let's say this. If I have insert add, and then I have some argument over here, and then I have require, and then we have do, and we have ensure, and end. Let's compare different possibilities. Over here, if I simply say something, and then I have old imp, okay? So this is one postcondition. Let's say I got another postcondition here. I say something here, but now I have old imp dot twin. That's postcondition number 2. Let's say I got a third postcondition. Somewhere I got old implementation dot deep twin. Okay? Over here I'm using old keywords 3 times. Okay? Accordingly, IFO is going to create 3 variables behind the scene and try to catch them. Okay? The way they catch is by simply doing in assignments. But because the expression over here is different, one is imp, the other one is imp.twin, the third one is imp.deep twin. So now it's going to be a difference. Let me show you. So now I can say over here, behind the scene, before the do is executed, we're going to have something like this. Old imp is assigned to just imp. So what does this do? It's going to make a reference copy of the implementation, right? That's how the cache will do. And then, what about this second expression here? It's going to say old, for example, imp twin. There's another variable here. It's going to be exactly this expression here verbatim. It's going to be imp dot twin. That's the second one. And what about the third one? It's going to be old imp and then deep twin. And this one here is assigned to imp dot deep twin over here. You can see that this corresponds to exactly the three expressions we have in the old expressions, right? So you can see the way you organize the old expression in the post condition is going to affect how they store the old values behind the scene. That's why writing imp versus imp.twin make a difference in your lab number 1. And we'll see that for this particular example I'm going to show you, it's going to also make a further difference because imp.twin is not going to work. Only imp.deepTwin will actually work. Yes?
So let's say the post condition here is trying to
Uh-huh.
compare it to primitive values. So you only need to go hold in.
Yes. It's a very good question. The question was, let's say the value I want to compare between the pre-state and post-states is only, let's say, integer, very simple value. In that case, you don't have to make any copy. You're right. On the other hand, if depending on what kind of change you're going to make to the data structure, let's say array, I will show you that in the array in general, you better make a deep twin. Okay? What you did for lab number 1 is because the way we changed the array container was very restricted. You only reorganized the order a little bit. So twin would be okay. Guys, please. Okay, yeah, so now for this particular example there, we're going to see that for the elements in the array, we're going to change the content. So you're going to use a deep twin. Okay? Okay, let's see how we can do that. Okay, so that slide basically done, just showing you how you can check the contract at the runtime. But most importantly, you have noticed that whenever you use the old keyword, that's going to affect the way IFO caches the value for you. Okay, now let's talk about what do we mean by complete contracts. This idea is very important. So what do we mean the contract to be complete? So now in the post condition especially, you want to somehow to say for every attributes, we're going to make some check, make sure for every attributes. Okay? We're going to compare the pre-state value and the post-state value, okay, for every attributes. We'll see example where you simply just compare some attributes but not others. Okay? However, when you're trying to compare the pre-state value and post-state value for certain attributes, it can be very tricky. If somehow the structure for the attribute is actually not simple like an integer, it can be composite, like array, linked list, or hash table, right? So now, so array, linked list, you gotta be careful. Let's say in this example, when you do arrays. If they're simple structure, then you don't have to worry about a copy issue. You don't have to. So now, this is how you should specify the updates for any composite data structure, let's say for array. And you pretty much got this intuition already from lab number 1. First of all, we want to say the intended change is already present. Let's say we want to insert something into position I. That part has been done. But the second part is even more important. We want to make sure the rest of the data structure is untouched. Okay, that's what we want to make sure. And the second part, how do you do that? You have to use a cross keyword, a cross construct, like quantification. Plus, you got to use some twin or deep twin. Okay, the second part, you have to make sure you don't have any aliasing problem there, in which case you got to choose between reference copy, shallow copy, and deep copy. And the structure itself might contain many, many elements there in the array or linked list. In this case, you better use the across keyword, okay, to actually iterate through. Okay, let's see example here. So we have 2 classes only to consider. First of all, we have a class called account. Okay? In the account class, we have only two attributes. We have owner and balance. Owner and balance. String and integer, very simple. And the constructor simply just create the owner and initialize balance to be 0. Okay? And we also got several methods, just a few methods here. We got deposit, which will simply just add a balance. And we also got is equal feature. In that case, we simply make sure the owners are the same and the balance are the same. Okay? That's about the class for account, very simple. Okay? Let's see how we can do for bank. So now let's add a complication here. For the bank class, it has, this is a critical attribute to pay attention to. You can see it has an accounts attributes, which is of type an array of accounts. Okay? And then initially we simply create the account to be empty. And we support two features over here. Let's say over here, this is the first feature, account of. Let's say I give the name of an owner. I want to retrieve their account objects. For example, if I say account of Steve at the name, if Steve exists, I'm going to return the account associated with Steve. And what should be the precondition for this? It should be that Steve should exist in the bank, right? So I'll leave this to you to see why this is the case. Like an existential qualification. You can simply use the sum keyword over here. Okay? Now, and you can also complete the definition here. I'll leave that to you. And the postcondition simply, the owner is simply equal to the name we set. Second feature, we want to add a new account into the bank. And how do we do that? The precondition is kind of the opposite. If you want to add a new account to the bank, it's better that the account does not exist just yet. So that's why it's going to be the opposite. So we just got another across over there. We're going to say across the accounts, and this no name, currently that's the same as the new name. Okay? And then we're going to just do this, we're going to use the force to add the accounts. Okay, any questions over here? So we only got two features we're going to assume that work. We got account of and also add. Questions? Okay. So now this is the roadmap of illustration. We're going to compare 5 different versions of this bank account and bank, 5 versions. And specifically, let's see, this is the feature we want to implement. Okay, deposit on. Remember, in the bank we have an attributes accounts of array type, and we want to say, let's say Steve and Bill, they are now the only 2 clients in the bank. We want to say, let's deposit maybe $100 on Steve's account. Okay, that's kind of deposit on we can implement. Okay, very simple. Now we're going to see 5 versions there. I'm just going to show you what kind of how we're going to gradually build. Okay, all the source code is also posted on the website. You should really look into that in detail. Okay, so we got 5 versions here. Basically, the first version, we're going to see some contract that's simply just incomplete. It does not consider all the attributes. Okay, that's not satisfactory. Second version there, we're going to see some wrong implementation, which will not be caught by some incomplete postcondition. So that's not satisfactory. And then the third one, we'll try to make the contract complete, which means we also compare the array attributes, but we only use reference copy. Again, the postcondition does not catch the error. There's no postcondition violation as expected. So again, that's not satisfactory. The fourth one, we're going to do a complete contract, but it's only shallow copy, only twin, like what you did for lab number 1. And that one still is not going to catch the error. Lastly, we're going to see when we try to use deep twin in the contract over there, we're going to see that it will give us some postcondition as expected. Okay? So now the key thing is, when something goes wrong in the implementation, we do expect some postcondition violation to occur. In that case, if your contract is not good enough, it is not going to report the error, as we learned from lab number 1. But we're going to show you in this case, only the last case where we use deep twin in the postcondition, it is going to report the error. Only that case. Okay? Okay, that's the kind of roadmap, and let's see. We still got about 15 minutes. Hopefully we can go through as many as possible. Okay? So now, this is going to be the setup we're going to consider for each test case. We're basically going to run almost the same implementation almost the same test case for all the 5 versions. The only difference is we're going to change from reference copy like imp to shallow copy.twin and also deep copy.deepTwin. That's the only difference we're going to make. So now let's just have a look at this particular object structure here. We have a bank called B, and the accounts has only 2 accounts over there, only 2. Okay? And the first account is simply just Bill, and the second account is Steve. Okay? Now we want to see if I want to deposit, let's say, onto Steve's account for $100. In this case, I should only change this particular object only, right? Only this one here, from 0 to 100. That's it. The wrong implementation is going to do something additional. It is also going to modify Bill's account as well. In that case, that's wrong. And only the last version is going to catch this error. Okay, that's kind of the issue. Okay, let's dive into the code and see what's going on here. Any question about the big picture before I move on? If you understand this big picture here, I think I will try to guide you through as much as possible in today. You should really study that over the long weekend. Okay, let's see what we have. Version number 1. Let's see what it means to be incomplete for the contracts. First of all, let's say we have, I just say deposit on version 1, just to disambiguate. Okay, that's version 1. So let's just go over this very quickly. The implementation part is going to be more or less the same for each version. How do I deposit on a particular name with some amount? So first of all, I got to make sure the account actually exists. I can just use a cross. I can let you follow that. And then I can simply run a loop. I can say from lower until larger than upper, if the current account I'm looking at has the owner just the same as the arguments. In that case, I'm going to deposit into that particular account. Okay? Otherwise, I'm just going to skip. Okay? So this is so far the correct implementation. Let's see what contract. So this implementation is correct. Okay? So now what about the post condition here? For version number 1, you can see first of all, we say that accounts.count is equal to old accounts.count, which means we don't really modify the size of the array. That's 1. And the second one, we say that since we are trying to deposit into this particular account owner with name n, and we say that if we try to retrieve that account from the new array and then request its balance, the balance should be equal to its old balance plus a, right? That's kind of just showing that particular account. However, this is kind of incomplete. Why? Because if you look at the diagram again, let's say if we only want to deposit onto Steve's account, in this case, the contract only covers this object only. It does not cover what about the rest of the accounts. Maybe there are actually a million other users, in which case you got to make sure every one of them stays unchanged. What if the implementation mistakenly also deposit on other accounts, in which case it's wrong. Okay, so first of all, the reason that the first version there is simply not complete because it doesn't really check that others unchanged, like what you see in lab number 1. Okay, let's see why this is a problematic. Let's see. So now let's try to do a test. Okay, if I do that for test number 1, for the version 1, again for version 1 over here, one thing I want to notice. This implementation over here is absolutely correct. If you're lucky, if the supplier gives you the right implementation, incomplete contract might survive. However, in version 2, I'm going to inject some mistake into the implementation, and the same incomplete contract is going to suffer because it cannot catch this. Okay? Version number 1, we simply just say we create a bank object over here, add Bill and add Steve, exactly like the diagram I showed you previously. And then I'm going to see how it is going to deposit. In this case, because deposit on version 1 does exactly the right thing, so that's okay. I want to make sure after I deposit $100 into Steve, Steve's balance becomes 100 and Bill's balance remains to be 0 by default. Okay? Version 1 is okay because implementation was correct, but you cannot rely on that. It can be wrong. Okay, version 1 is fine. But now let's see version 2. For version 2 over here, everything is pretty much the same loop. I just wouldn't repeat. Now, there's something new. I say that if you want to deposit into some name, let's say Steve, at the same time, I'm going to go to the very first account in the array and then deposit the same amount there. In that case, Bill. That's apparently wrong. Now, if we review the same contract from the version 1, is this going to catch that? No, right? Because for the first one here, in the wrong implementation, we still didn't modify the count of the array. We didn't grow it or shrink it. And this part over here only talks about Bill. Oh, sorry, it only talks about Steve. Only the account we want to deposit on. It does not care the rest of the account owners. Okay? So this one here is not going to give you any post-condition violation. Okay? So what you will see is, now if we run this test over here, is this result going to be true anymore? No, because now bill.balance will be just 100 by mistake. However, if you look at the test over there, what you will see is, check assertion violated, not post-condition violation. Because somehow we expect the correct behavior would be this line over here, the red line, they should throw some post-condition violation mistake, but it didn't. It simply just let it pass through. And then we as a client, we realize, oh, we got something that's really unacceptable. I only want to deposit into Steve, but you actually deposit to Bill as well. Okay? So now, what's really wrong here is we should really see some post-condition violation here. Well, that's what we should really see, right? Again, what does it really mean when the post-condition is good enough? That means anything that goes wrong in the implementation can be caught somehow by one of the post-conditions. That's what you did in lab number 1. Okay, that's version 2. So far we talked about 2 versions already. So now we're going to see how the remaining 3 versions are going to make a difference. Let's see them one by one. Okay. Now, first of all, for version number 3, so the implementation is the same as before, so we also got this wrong one. Okay, so now we're going to add one implementation there, only one. I'm going to add one post condition there. Sorry, it's been hanging on me. Over here, you can see we got one more post condition there. It's called others unchanged over here. So here you can see we only say old accounts. Remember what I said before? If you only say old accounts, that means implicitly behind the scene, before this feature here is executed, implicitly there will be an assignment to say old accounts is assigned to just accounts. In this case, it's making a reference copy, right? So now if you try to go over this test over here, it's going to see the difference, okay? It's going to throw the post-condition violation. Let's see that very quickly. Okay, let's say this is what we have, okay? So over there, you're basically saying, so here in the post condition, in the ensure, you simply say across old accounts. In this case, what you will do is, you will simply just make a reference copy before that. Only that, over here. And then, so this is the old accounts, like that. So when the wrong implementation there try to change something, let's say it's trying to deposit 100 into here, and then also deposit 100 into here, but because of aliasing, right? In this case, you're trying to say, let's just review that. You're going to say across all the accounts over there, every, apart from the one we want to deposit into, every other account is going to have their account owner stay unchanged. Okay, the account stay unchanged. In this case, if you see the diagram here, if I try to compare these two things, this one here and this one here, it's going to be trivially true, right? Because you can see they refer to exactly the same account and exactly the same. There's nothing for us to compare, really, because they just refer to the same objects. Okay? Questions or more explanation, or are we okay? Guys, gotta speak up, right? If you're really confused, you can say that. Yeah. Yeah. You mean over here? The second one here. Yeah, the second one here basically say, let's say I want to deposit into Steve. Okay, I want to say after the deposit has been done, the account of Steve, the balance of it should be equal to the same account, the balance, plus A. No, Steve is okay, because the wrong implementation, not only that it will do from 0 to 100 for Steve, also you're going to do something additional. Yes, exactly. Yeah, okay, good. Okay, are we okay with this? Okay, so now let's go to version 3 very quickly. Kind of the story goes on. So now for version 3, when we only did a reference copy, it's not going to throw the postcondition violation. So now, that's why we go to version 4. For version 4, we use .twin. Now, we're basically doing something that we did in lab number 1. You might think this will work. No, it's not going to work. Because now we are not really trying to reorganize Steve and Bill in the account, let's say to swap their position. In this case, we are changing the object itself, so it's not going to catch that. Let me show you the diagram. Okay? So now you can see that basically everything else is the same. I'm just saying old accounts.twin over here rather than just accounts. Okay? So now let's go back there and let's see how it's going to help. Okay, over here. So now over here you can see in the insure over there we have something across accounts dot twin. If I simply say that, what does that mean? That means we're going to make some new structure over there, right? Accounts refer to this particular array over here. Since we said accounts.twin, that means we're going to make a brand new array, okay? Which means something like this. It's going to be something like that, brand new array only at the first level over here. And then, so this is accounts dot twin. And then everything else will be a reference copy, which means the first position here is going to refer to here. And the second position is also going to refer to here. That's a shallow copy. Now, the question again, is this going to catch the error that when I say change this from 0 to 100, that's the right implementation, right? However, the wrong implementation also does something additional. It also changes this from 0 to 100. But now, is this going to catch the error though? No, because when you say accounts.twin, when you talk about accounts.twin at position 0, it talks about this object here. When you talk about the original account, the new accounts at position 0, that also talk about the same object. So it cannot distinguish. Okay, that's the issue. Okay, so now we know that if you only swap the order of these two accounts, twin would be enough. But if you try to modify the contents of the objects, no, it cannot catch that. Okay, finally, so that's why we need to go to the very extreme. So if you try version 4, it will still not give you the post condition as expected. So what you really got to do is you have to say, with the wrong implementation there, you have to say old accounts.deep twin. That's what you really got to do. Okay? Let me just show you the diagram, and then I'll summarize. The diagram here, so now over here you can see the insure over there is going to say across accounts dot deep twin. Okay, that's what you will get. So this will trigger some copy like this. So now what we will get is something like this. So you have accounts dot deep twin. And then first of all, it's going to point to a brand new array. And then it's a deep copy. So it's going to go recursively to all the object structure, which means the accounts is going to be recreated as well. Over here, you got accounts, you have owner, you have balance, you have owner, you have balance, and then So here, this is Bill, and this is Steve. 0 and 0. So that's the old one, okay? So this is the old one. So now, the incorrect implementation there, you can see this will be changed to 100, which is correct. But now this is changed to $100, which is incorrect. But now when you compare the old imp.twimp and also the current imp, can you actually compare the difference? Of course you can. Let me highlight that. Because you can see this object over here is expecting 0. But this one over here is 100, so they're different. So this post condition will actually catch that. Okay? That's why making a deep copy does make a difference in this case. But the other previous one, either reference copy or shallow copy, they cannot tell. Okay, one moment. Wow, guys, only still 5 minutes, right? Yeah. Hang on with me. Well, I don't want to let you go because you're gonna study this, right? I want to make sure you're ready. Okay. Anyway, so if you run the source code over there, only version 5 is going to give you the post condition violation. Okay. And now there will be some exercise over here, which I'll let you think about. So let's say we have a new feature over here, and you want to figure out what should be the post condition. I can tell you that I got different possibilities for you. Only one of them works. Working groups, think about it deeply to see why only the last one where we use the tilde, which means object equality, right, will only work. Only that will work. But all the others wouldn't work. Look into that and then drop by my office hour if you've got questions. Okay? Now, there's no class on Monday. Let me just finish it in 1 minute. There's no class on Monday. There's Thanksgiving. So on Wednesday, I'm going to start the iterated pattern. But for the lab test, it's not going to cover the iterated pattern. It's going to cover everything until now. Okay? Okay, see you next week.